So here we go with example 9 from chapter 2.2 of the A2 Pure. So as usual, we need to read the question carefully at the start. The function f of x is defined by f such that x is mapped onto 5 minus 2x for x less than 1 and x squared plus 3 at x greater than or equal to 1. Sketch and state the range of f of x and then solve f of x equals to 19. So, first thing we want to look at is this interesting point where x equals 1. So if we look at the top half of this equation and substitute in x. So when substituting x, we get 5 lots of minus 2 lots of 1 is equal to 3. And 1 squared plus 3 is equal to 4. Now that's quite unusual as a question and as a design of something, because what we've got at this point, x equal 1, and x equals 1 in here, these outputs are different, which is very unusual. So that suggests the graph instantaneously jumps from 3 to 4, and therefore we've got what's called a discontinuity. Yeah? We've got a discontinuity at x equal 1 as the values are different. Okay, so let's sketch the graph. For x less than 1, we've got a straight line graph. Y-intercept of 5, gradient of minus 2, so it's coming in quite steeply, and then we get to 1, and we know that that point there, the end of the graph, at x equal 1, coming from here, must be 3. So that's going to be 3. We know that the next part of the graph for x equals 1 is a quadratic, and at x equals 1 it's starting at 4. So up here, slightly higher up, we've got the value 4, and it starts there, and it's got a standard quadratic shape. Now just think carefully, will it be the bottom of the curve or is it already increasing? And I think we can be fairly confident it's already increasing at that point, because the bottom of the curve, where the smallest value will be 3 at x equals 0. Yeah, I'll just sketch that in. So it would have been here. Yeah, but we haven't got that bit of the graph. Okay, so let's just undo those, take them out of the equation. Oops. Let's draw that back. What's happened now? Smooth, nice smooth curve, and it's going to be going up like that. Now, we also need ways of showing that the discontinuity, which value we're actually including. So like when we've done inequalities before, the 0, the dot that's not coloured in, shows the point is excluded. Point at x equal 1 is excluded. And here at the other end, or where it's jumped to, we've got a solid dot, which is showing us that point at x equals 1 is included. And we know that because of the differing inequalities. Yeah, that's coming from x is greater than or equal to 1, and this is coming from x is less than 1. So it's excluded or included with it equal to 1 and excluded because of the less than or less than sign. I hope that's clear. Okay, we can now move on to part B. F of x equals 19. Well, if we go back to the graph, that's a really helpful starting point, because f of x, remember, is our output values. Yeah, so our output value is 19. So that will be way up here on the axis. I've probably not drawn higher up for the scale. But the output values are 19. What input gives that? Well, we've got two solutions. We've got one from our straight line and one from our quadratic. So at f of x equals 19, we could have x1 and x2. So let's think about x1. That's the straight line graph, so 5 minus 2x is equal to 19. That's coming from this straight line graph using that equation. And now we can solve that. So move the lowest number of x's to get the number of x's positive. Subtract the 19, so we get minus 14 equals 2x. X equals negative 7. I'm slightly reassured by the negative 7 because where did we say x1 was? Yeah, in the negative part of the graph. Now we're going to look across to the other side. So at x2, we can see that x2 is coming from the quadratic part of the function. So x squared plus 3 is equal to 19. X squared equals 16. X equals... Now, you should be in the habit of thinking that it's plus or minus 4 when we square root. But here, we look at the graph and we can see that we don't need the negative value. It's only the positive value because the quadratic curve section all is positive, and if we look back to the question, x had to be greater than or equal to 1. So our two answers then are x equals minus 7 and plus 4. Okay, homework from this section. Exercise 2b. Questions to try. Question 2. Question 4. Seven, 8, 9, and 12 should do it. If you're feeling brave, you can try some of the others.